Hello, you are welcome. Now the question under electricity here says two cells, each of EMF 1.5 volts and internal resistance 2 ohm are connected in parallel. What current will flow in the circuit if two resistors 3 ohm each are connected in parallel across the circuit? Now we have to start by taking note of the EMF formula. Now the EMF formula is saying that E is equal to the current. E is the EMF is equal to the current multiplied by the sum of the external resistance and the internal resistance. So this is the EMF formula. Now for us to apply this, we have to get the effective value. Don't forget we are looking for currents. So we have to get the effective EMF, we have to get the effective internal resistance, and then the effective external resistance. Don't forget these effective values are the combined values. So for the effective EMF now, I'll say E. Don't forget the question says there are two cells, each of 1.5 volts EMF, and then they are connected in parallel. So when you have two cells that are connected in parallel, their effective EMF is just to take the EMF of one of them. If it's in series, you can add them together. But once they are in parallel, you just pick the EMF of one of them, and that gives you the total EMF in the circuit. So the effective EMF in this case is 1.5 volts. That is the EMF of just one of them. Now let's go ahead and look for the effective internal resistance. So the effective internal resistance, that is small letter r, which is the internal resistance. The effective internal resistance is given by this formula, just one of the internal resistance divided by the number of cells. So this formula can be used to obtain the effective internal resistance. So you just pick one of the internal resistance of the cells, and from the question, the internal resistance of this cell is 2 ohm. You can see it here. So we just pick 2, that is 2 ohm, and then divided by n is the number of cells. So if you look at the question, we have 2 cells. So we divide by 2. So 2 divided by 2 is equal to 1. So the effective internal resistance is 1 ohm. So that is the effective internal resistance, and we also have the effective EMF. Finally, we go to the effective external resistance. Don't forget the external resistors here, we have 3 ohm, and there are 2 of them. 2 external resistors that are connected in parallel. Don't forget the question says they are connected in parallel. So when resistors are connected in parallel, we can use this parallel formula that says 1 over R is equal to 1 over R1 plus 1 over R2. We can use this formula to find their effective external resistance, to find the value of R. But since they are equal, don't forget the two resistors in parallel, that is the external resistors in parallel, they are connected in parallel, that is the external resistors are connected in parallel. So because they are connected in parallel, what we need to do is to simply use this formula that is similar to this. So we say R is equal to R1, that is just one of the external resistors, divided by the number of resistors. N this time is number of resistors. Take note of that. Now you only use this formula when the external resistors are equal. You can see here that they are equal. Each one is 3 ohm. But when they are not equal, please use this formula when they are not equal. Use this formula to get the effective external resistance. But when they are equal, we can go ahead and use this formula. So one of the external resistors is 3 ohm. Don't forget the two of them are 3 ohm. So one of them is 3 ohm. So you just pick one of them, which is 3. and then you divide by the number of resistors. There are two resistors, two external resistors. So we divide by 2. So 3 divided by 2 will give us 1.5 ohm. So that is the effective external resistance of the circuit. And then finally, don't forget that we are looking for the current. So the current is question mark now. So back to our EMF formula. So we simply say E is equal to the current multiplied by external resistance plus internal resistance. So we're going to use this formula now to get the value of the current. So the effective EMF from what we saw at the beginning is 1.5. You can see it's 1.5. So I'm going to take 1.5, that's our combined EMF, is equal to the current that we're looking for, capital letter I, multiplied by the effective external resistance. You can see it here. R is 1.5. So 1.5 added to the effective external resistance, internal. The effective internal resistance, which is 1 ohm. So we'll say plus 1. And then we can simplify further and say 1.5 is equal to 1.5 added to 1 is 2.5. So I simply say 2.5 multiplied by letter I, which is the current, 2.5 I. So for me to get the value of my current now, I'm simply going to divide both sides by 2.5. So I say over 2.5 and I say divide by 2.5. So that 2.5 cancel 2.5 and I'm left with current. So I can try to write the current first. I'm left with current on this side and it's equal to 1.5 divided by 2.5 will give me 0.6. So that shows that the current in the circuit is 0.6 ampere. The unit for current is ampere. So A. And so this is the final answer. Hope you enjoyed this video. Please don't forget to subscribe to this channel so that you can get more videos like this. Thank you for watching.